Okay, I'm very happy to introduce today the renewable energy support schemes and instruments at European level, which are a main consequence of the policy discussion in Europe over the last decade, in particular the Renewable Energy Directive, the Renewable Electricity Directive for the year 2010, and the Renewable Energy Directive for the year 2020. I would like to start with a motivation of the regulatory background of support schemes, then give a classification of support schemes, and show some of the key results on the evaluation of support schemes in the European context, and then concentrate on market and system integration of renewable energy technologies and which tools are available in that respect, here in particular feed and premium systems and other elements, and last part of the presentation concentrate on auction-based systems, which are a new tool or used in Europe as a new tool for increasing market compatibility of support schemes. The general motivation of support and instruments is that one sees that negative externalities need to be corrected from the use of fossil fuels, in particular the externalities relating to climate change, so carbon emissions, and secondly, the innovation externality, achieving dynamic efficiency and reducing costs of new technologies by stimulating technological change through learning by doing and by introducing these technologies into the market. The institutional implementation of these policies currently is based on the Renewable Energy Directive 28/2009 and the characterization and the evaluation for that by the European Commission guidance on design of renewable energy support schemes. And clear objectives in this respect are that the desired share of renewable energies cannot be delivered by markets alone, but support schemes are needed to overcome market failure and increase competitiveness of renewable energy technologies, in particular to drive down costs. And in functioning energy market needs to be designed, and the renewable support schemes should be compatible with such a market, and the minimization of support costs for households and businesses is a clear objective in this respect as well. The features of support schemes, or the general requirements regarding support schemes at the European level, are that the flexibility and the freedom of choice should be with the member states. Then responsiveness to decreasing production costs should be assured. So when technology learning is achieved and costs are reduced, support schemes should react to that. Support should be gradually removed in this respect when renewable energy technologies become cost competitive, and therefore market integration instruments should be incentivized, and I think we are currently at this stage of transition to what's more market integration. The strengthening of investor confidence is a clear aim of European renewable instruments and policies, and in particular by avoiding any unannounced or retroactive changes of policies. So this is of course the worst case where capital costs would be increased and investor confidence undermined. Therefore, ensuring efficiency of renewable rollout by using also cooperation mechanisms between different member states of the European Union. The classification of support instruments can be generally done in terms of regulatory versus voluntary instruments, as well as direct versus indirect instruments. Regulatory instruments and direct type of instruments are the ones I would like to concentrate on today. These are the policies and instruments that are driven by EU member states to achieve the targets of the European directives. The regulatory instruments can be subdivided into investment focused and generation focused or generation-based instruments, and into price-driven or quantity-driven instruments. Most of the support instruments that have been used in the past are generation-based, so they give a remuneration for the generation of renewable electricity. And the key differentiation that took place in the past was between price-driven and quantity-driven strategies. And the main examples in this respect are feed-in tariffs as a price-driven generation-based strategy and quota obligation schemes as a quantity-driven generation-based strategy. And I would like now to introduce these two main policies. Here you see that a cost supply curve or supply curve of a renewable technology in a grayish color. And you see, depending on, there's a certain, there's a quite uncertainty about the cost of the technology depending on the potential. And in a price-based strategy, the regulator fixes a price and then a certain quantity is achieved, and depending on the level and the actual shape of the supply curve, the quantity is not exactly met, but has given uncertainty, but in that case the price is fixed and the quantity is the result of the policy, and the support is guaranteed for a specific period of time. The support is allocated to producers of renewable energies and covered by levies on consumers or taxpayers. One can also introduce feed-in tariffs which are not flat in the sense that they give the same price for all technologies or all locations, but so-called step feed-in tariffs which differentiate between, for example, different wind locations, where the most windy locations get a lower tariff and the less windy locations get a higher tariff. Here shown in the red curve and the black curve. In the red curve is the actual supply curve of, for example, a wind portfolio in a given country. And you see when you design your feed-in tariffs as shown in the black curve, then you can reduce producer surplus and therefore reduce policy costs for the consumer and therefore have the policy introduced at a lower cost in terms of policy implementation. The main alternative to feed-in tariffs in the past were quota obligations, either based on tradable green certificates or as introduced as non-tradable quotas, as in the past in the US in particular. In a quota obligation, the amount of renewable electricity that should be produced is set by the government by, for example, legally enforceable quota to produce a specified amount of renewable electricity. The main objective is securing the penetration of a predefined amount of renewable energy. So once the quota is fixed and the penalty for not reaching the quota is sufficiently high, one knows the amount of electricity that should be produced. One, as I said, one can differentiate between tradable and non-tradable quota. In the past, mainly, or in some states, non-tradable quotas have been introduced, but in the European Union, we have only seen tradable quotas for electricity, and the conceptual advantage of tradable quotas or tradable green certificates is that they fulfill or facilitate a fulfillment of the quota obligation by developing the renewable potential at the minimum generation cost and therefore increasing the economic efficiency in terms of the total system cost. At least in theory, this is the case because there is the focus on the least cost locations. Of course, in a uniform price feed-in tariff, it should be similar. If there's no technology differentiation and no site differentiation, then also there the focus should be on least cost locations. A tradable green certificate, therefore, is used to present the added value of the greenness of the predefined unit of electricity. So in a quota system based on tradable green certificates, the renewable energy generator has two types of income streams. If you here with the black bar imagine the value of the conventional electricity, and with the green bar the value of the renewable electricity, then you might subdivide this value of the renewable energy source into one part that represents just the conventional value of the electricity, and the green part that represents the additional value of the greenness of the good. And in a tradable green certificate system or quota system with tradable green certificate, you trade and you produce essentially two types of commodities. You produce electricity, which is traded at a market for conventional electricity, here indicated with the black bar, and on top of that, the light green bar is the greenness of the renewable electricity that is traded at a market for tradable green certificate, and the value at this market represents the value of the greenness of this electricity. Let's say the main disadvantage from the investor point of view is that he is now trading a good at two different markets with two types of uncertainties. The investor has the uncertainty of a future electricity price and the uncertainty of a future green certificate price, and therefore as a compromise between fixed feed-in tariffs and also the tradable green certificate, feed-in premium systems have been introduced where the investor or the generator also trades the conventional part of the electricity at the electricity market and receives market revenues for this. And on top of that, he receives a market premium which is fixed by the government, and where the sum of market revenues and market premiums should represent roughly the value of the feed-in tariff and the remuneration level of that. And on top of that, typically a management premium is paid, which remunerates for other additional costs in terms of market and system integration of the green electricity. The motivation of using this type of feed-in premium systems are the following. As I said, a higher investment security is achieved as compared to just a quota system based on tradable green certificates, because one has more certainty about the income stream. I will say a few words about that. There are different feed-in premium systems. In a so-called floating feed-in premium system, one has essentially a full guarantee of the income stream, very comparable to a fixed feed-in tariff. On the other hand, one has improved market compatibility with selling the renewable electricity at the conventional electricity market, and therefore this is an increased market compatibility as compared to fixed feed-in tariff. All different marketplaces for selling renewable power can be used, for example, also future markets and balancing markets, and it incentivizes renewable generator for being creative in creating better forecasts, for example, new balancing products, use of storage options, optimizing plant design and operation, and therefore it incentivizes renewable generators to maximize the value of their electricity. As compared to the generation-based instruments, I have mentioned that we also have investment-based instruments generally and conceptually available, which are, however, not used in any of the European member states as main support scheme. They are mainly used at subnational level or as complementary support scheme to the main support scheme, and we differentiate between grants and preferential loans as investment-based support schemes, and while production-based support schemes maximize the production irrespective of the price, investment support decouples the production from the sales price of the electricity in terms of euro per kilowatt hour. And the main disadvantage of investment-based support schemes is that they don't incentivize to maximize the production for a renewable plant throughout the lifetime. So it may reduce the incentive for improving operation and maintenance, for example, during the lifetime. Now, summarizing this, what I've shown from the differentiation of instruments between fixed feed-in tariffs and quota-based systems, fixed feed-in tariffs here on the left-hand side, quota plus tradable green certificates on the right-hand side, you see that in a fixed feed-in tariff, the government fixes the price, and the market decides about the quantity. So one receives a fixed tariff guaranteed during a certain lifetime of X years, and a purchasing obligation by the transmission system operator typically. And as compared to that, this purchasing obligation is no longer valid, but the power is sold on the conventional market. And there are different ways to design the sort of feed-in premium, whereas a fixed feed-in premium gives the same premium in every hour of the year, irrespectively of the price of the electricity at the electricity market. A sliding feed-in premium would give the feed-in or the level of the premium such that the feed-in tariff, the level of the feed-in tariff is reached on an average basis, for example, as an average over a month or a year. And on the right-hand side, in the quota system, both income streams fluctuate over time, the market price as well as the revenues from selling tradable green certificates. And in this quota system, an obligation is typically given to suppliers, for example, for a minimum share of renewable electricity. This has to increase over time in order to leave the incentive to install new capacity and to make sure that the certificate price doesn't collapse. And it has to be equipped by a penalty, because otherwise, there's no incentive to build renewable electricity plants, only if the non-fulfillment of the quota obligation is penalized. There will be a sufficient incentive. And power is sold on the conventional markets and green certificates at the green certificate market. Which instruments do we have in Europe at the moment? We see that in Europe the landscape is quite scattered, and the majority of member states currently uses feed-in tariffs or feed-in premiums. We have a clear trend towards feed-in premiums, and important countries that use quota systems in the past were Italy and the United Kingdom. And these are here shown in a shadowed color, because the United Kingdom changed from a quota system to what they call contract of difference, which is the same as a floating or sliding feed-in premium. And the same instrument is introduced in Italy, which also switched from a quota system to a sliding feed-in premium. And since the old plants are still receiving or work under the quota system, and the new plants under the feed-in premium, both systems are depicted here. But like countries like Germany or Spain and other countries have feed-in tariffs, feed-in premiums introduced at the same time, and many countries like the Netherlands, Finland have a pure feed-in premium introduced. For new plants, for example, in Germany, there has also been the switch to a feed-in premium. So to summarize very quickly, feed-in tariffs and quota obligations based on tradable green certificates both create an artificial market, either by setting the price, as in a feed-in tariff, or by setting the demand. And by setting the price, one has uncertainty regarding the future demand of renewable generation, and by setting the demand, one has uncertainty about the resulting price. But sometimes when people call quota systems more market-based instruments, and actually this is hardly the case from my point of view, because both instruments introduce an artificial element, either by setting a price or setting the quantity. There has been, of course, a lot of debate on what are the pros and cons of these two, the two main paradigms of instruments in Europe, and the protagonists are arguing for a fixed feed-in tariff, mentioned particularly the low investment risk the high technological diversity, low windfall profits for mature technologies because the tariffs can be made very technology and site specific, and a broad spectrum of investors. However, the main disadvantage, also acknowledged, was the low compatibility with the electricity markets. On the other hand, technology quota systems have higher compatibility with the electricity markets, competition between generators, but high risk and uncertainties from the investor point of view, and therefore higher risk premia and low incentives for less mature technologies, and on the other hand, high windfall profits for the very mature technologies. And therefore, the development of compromises was in the clear focus of the last year, and first, feed and premium with fixed electricity price index were introduced, and on the other hand, banded quota systems were introduced in order to integrate technology differentiation into quota models, and we are currently now in the process of finding the ideal compromise, avoiding disadvantages and maximizing advantages of each of the instruments. There has been a lot of effort in evaluating the instruments at the European level, and of course there's a long list of evaluation criteria, in particular effectiveness in terms of target achievement, efficiency, static and dynamic in terms of reaching the target at lowest cost, system conformity, practicality, reliability for industry and investors, transaction costs, etc. I just want to focus here on the effectiveness and the efficiency of the instruments, because these criteria have been the main criteria used by the European Commission. And you see here the effectiveness indicator as it's defined by the evaluation reports used by the European Commission, where you see the generation of a technology in a country, like for example, take biogas in the UK, and you have generation in the year 2002 and 2003, and the difference of this generation divided by the additionally available potential in a certain target year, like in the year 2020, is called the effectiveness indicator. And this is shown here for the case of wind onshore for the period 2011-2013. And we see here in different color codes, again, the different instruments used in Europe. And you see that regarding the effectiveness, whereas in the past, countries with FIT and tariffs and FIT and premiums have been substantially more effective. This is not necessarily like this anymore. We see that FIT and tariff countries can be very effective, like Denmark, Portugal, Germany in that case, but also some of the quota countries like Romania, Sweden, and Belgium have been relatively effective, so have increased their markets. However, we see large heterogeneity between European member states. However, if you look at the so-called efficiency, so the cost of reaching these targets, we see large differences between European member states. Here in blue bar shown the minimum to average generation costs, and in the red dots and bars the average to maximum remuneration, so the payment to the renewable generation. And you see that in some countries these are very well aligned, like in Denmark, in Spain, and France, where the remuneration agrees quite well or matches quite well with the cost levels. And you see, however, in quota countries like in the UK, in Romania, also in Belgium to some extent, in Italy, the support levels are substantially higher than the generation costs. So it seems there are reasons for over-subsidizing in these markets. And the key element is here, as I mentioned already, the higher risk level regarding the revenues, and therefore risk premia introduced by investors, and sometimes also technology neutral support, where wind power is not the cheapest technology and therefore receives windfall profits due to higher support for more expensive technologies. And we see here the cost effectiveness shown as a function of the policy effectiveness of the instrument, as shown as a function of the profit range. And we would assume that the countries with the highest profit ranges also are the most effective countries. And this is not necessarily the case. We see countries like the UK, but also here Greece, Hungary, Slovenia, where we have relatively high support levels and therefore consequently relatively high profit ranges, where the effectiveness is very low, so the markets grow very slowly. But we see other countries like Portugal, Sweden, Denmark, where the profit level is very moderate and still the effectiveness is relatively high or very high. And this shows that political stability, as we observed in these countries like in Portugal, in Sweden, in Denmark, and the reduction of revenue risk is a key element for reducing the cost of a policy, but also increasing the share of renewable energy. Here, just one example of the development of policy costs for renewables in Germany. We see here for the different technologies that costs have developed quite dynamically over the last years, reaching now a level of roughly 20 billion euro per year. And at the same time, due to reducing CO2 prices and increasing shares of renewables, the reduction of the market value at the conventional power market for renewable technology. And this is actually a challenge for the future in order to make sure that competitiveness of renewables can really be reached. And in the different reforms of the Renewable Energy Act in Germany, it is now taken care that by, for example, focusing the technology portfolio on the cheapest or lowest cost technologies, and by auctioning the remuneration level to keep the support level and remuneration level moderate in order to make that differential costs, so additional costs of renewable support, saturate and will also decrease in time in the next years. A key debate also introduced by the Commission guidelines and environmental state aid guidelines is the market and system integration of renewable technologies. And in this respect, the Commission is asking for feed-in premium systems. What is the key element or physical element behind that? Important is that renewable electricity generation creates fluctuating spatial and temporal generation patterns in the power systems, which are dynamically varying and lead to complex congestion patterns in the transmission grid. And therefore, new challenges for forecast of power generation result in new requirements for flexible intraday dispatch, balancing products, and of course this leads to costs in the overall power system. And therefore, there is the clear need that also renewable generators receive some responsibility for market and system integration. And the question is which contributions can renewable generators bring in this respect. And the four most important elements here are quickly increasing renewable energy shares require a higher market integration and system responsibilities from renewable energy plants. And therefore, renewables should react to system demand in the periods of low or negative electricity prices. Renewables should be balancing responsible by fulfilling their own schedule of balance and activate the creativity of renewable generators to facilitate the full flexibility of the system. And renewable operators should provide good forecasts in order to have the full information for dispatching also the conventional energy system. And in order to actually achieve these requirements, feed-in premium systems have been asked for by the Commission as the main instrument. And these feed-in premium systems can have different implementation options and design options. And one option is whether they are introduced mandatorily or optional, and with different intervals to change between the feed-in premium system and the fixed feed-in tariff system. They can be introduced as a fixed feed-in premium, cap and floor, or sliding premium. There can be different methodologies to determine the reference price, for example, on an hourly, monthly, or annual basis. And there are different methodologies to determine the balancing costs, which are also another element of the remuneration under a feed-in premium system. I already showed this graph, but I just want to quickly repeat it. Just look at the 3 bars for the feed-in premium system. Here on the left-hand side shown is a fixed feed-in premium system where the level of the premium is always independent of the electricity price. However, this can lead to losses on renewable generators if for long-term low electricity prices are observed in the market, and can lead to excess profits if electricity prices are very high. Therefore, in such systems like in Spain, cap and floor elements were introduced where the total remuneration is capped at the cap level and filled to a floor level in order to reduce the risk both for society and investor. And bringing this to an extreme, one can also introduce the premium such that on a certain average, like a monthly or yearly average, with a benchmark of the average monthly or yearly electricity price, the sum of electricity price and premium is always fixed at the fixed feed-in tariff. And this type of floating premium or sliding premium, which is shown on the right-hand side, is now the dominating premium option because it combines the requirement of certainty for investors on the one hand side, and the market introduction of renewable plants, because renewable plants still have under the system the incentive to behave according to the market signals. So the support premium in this case is determined by taking the fixed feed-in tariff and subtracting the benchmark for the conventional market value and adding the management premium, whereas the market value represents the, for example, monthly or yearly average of the market value of the national technology profile, for example, for wind power or solar power, and the management premium covers the cost of the balancing of the renewable energy portfolio. And these feed-in premiums, as I said, fulfill many elements that are needed for a better market and system integration, and I just want to quickly go through the 4 most important elements that are needed in the future in order to integrate large shares of variable renewables into the market. First of all, a demand-oriented electricity production will be needed in times of very high shares of renewables. The aim is to shift generation from periods of low demand into periods of higher demand, and this could be applied also under a fixed feed-in tariff by introducing high tariff or low tariff periods in the residual demand, but in a feed-in premium or quota system using the hourly electricity price, this is automatically reached. And there can be different variants in terms of obligation for plant operators. In a fixed feed-in tariff, there can be the obligation for the plant operator to behave demand dependent. In a feed-in premium and in the quota system, this is more or less automatically reached through the level of the electricity price as a main element of the income stream. The next element is the balancing responsibility, where renewable energy producers have to fulfill their own schedule of balance at the electricity market, and therefore one shifts a part of the balancing responsibility from the TSO to the plant operator, and this is reasonable in generally in order to bring a competitive element in acquiring these balancing products. And in case of feed and premium and quota systems, typically the full transfer of the balancing responsibility to the renewable generator is implemented. And in case of a fixed feed and tariff, this is more difficult. There have to be penalties and bonus payments defined in order to keep the electricity generator balancing responsible. For example, in Spain, this has been introduced in the past. Another element which is also relatively important is for renewable generators reaching higher shares in the electricity market is an online plant control and online dispatch possible by the transmission system operator. This is of importance in order to increase the system stability in case where the transmission system operator has to avoid extreme events and based on avoid critical situation in the transmission grid. And this can be in principle introduced in all support schemes that I have mentioned here. Important is the provision of the access to the plant data. And here I think Spain is also a very good example where a so-called control center was introduced in order to give the transmission system operator the chance to remotely control the renewable power plants in order to maximize the stability of the grid. And last but not least, one very important element for system and market integration is the provision of system services, for example, balancing power, reserve power, and introduction into the intraday market. These type of system services are a key reason why a certain minimum must-run capacity is still part of the power system. So in times of very high renewable generation and low load hours, so a very low residual load, typically in countries with having high shares of renewables have to be curtailed at the level of this so-called must-run capacity. And this must-run capacity of conventional plants can only be reduced if renewable generators take the responsibility of conventionals in order to provide system services for stability of the grid. And these system services, as I said, are mainly based on provision of positive, negative balancing power. And here again, in a feed and premium system, there are better framework conditions for renewable generators because they are already offering their electricity in a range of different markets, and so offering it also in balancing markets is just one natural way of trading the electricity. When evaluating these key measures I have briefly introduced, demand orientation of renewable generation, balancing responsibility, online monitoring, and provision of balancing power, one can see that most of them are already fulfilled in feed and premium systems or quota systems. However, most challenging at the moment is still the provision of balancing power, because this relies also typically on a change of the provision of the design of balancing markets on the side of the conventional power system. For feed-in tariffs, most of these elements are more difficult and need extra regulation within the feed-in tariff design. Last but not least, I would like to say a few words on auction-based systems. In Europe, in the environmental state aid guidelines, the European Commission requests also a transition to auction systems, and member states are currently eagerly introducing auction systems. And currently in feed and tariffs, feed and premium systems, the determination of tariffs is still based on administrative tariff setting based on the levelized cost of electricity. This involves the risk of excessive or insufficient support if the tariff is wrongly estimated or the costs are wrongly estimated. And the increase of cost effectiveness would, in the long term, require more competitive price formation. So in that sense, it is reasonable to request that the prices are not set administratively forever, but are set based on competitive market actions. And auction tenders offer an option to introduce these elements of competitive price formation and at the same time provide the opportunity for volume control. So automatically by applying tender auctions, one allocates a certain predefined volume of installed capacity of financial value. And in practice, typically auctions tenders are combined with FIT and tariff, FIT and premium systems. And there are different design variants. I would just at the end briefly mention. Typically one important element is that tender auction systems are not an independent support system, but are typically a combination with other main support systems like FIT and tariff, FIT and premium systems, or even in quota obligations, the value of long-term contracts can be defined based on an auctioning system. And there are different auction types. One divides in particular single or multiple item auctions, where like in a single item auction, only one bid project wins, like an offshore wind in Denmark is an example, where in a multiple item auction, several bids are selected in the auction procedure. This is the typical case for renewable energy auctions. One can differentiate between a static and a dynamic auction. In a static auction, bidders have no information on other bids and just bid once. In a dynamic auction, like in a descending clock, the bidders react dynamically to each other's bids. And for a dynamic auction, the Brazilian case for a descending clock auction for wind onshore is a very good example where very competitive prices have been reached. And one can differentiate between pay-as-bid and uniform pricing, where in the pay-as-bid auction, each winner receives the price as bid, and in a uniform pricing case, all winners receive the same price, namely the clearing price. And here, there's still some experimenting. In Germany, for example, for large-scale PV systems, auctioning were introduced, and we have seen the first results. And here, both auction types will be used, and the results of the two types will be evaluated. I think I will stop it with here. I would like to advise you for the different sources where you can find more and the full information of the aspects provided in this lecture. And I'm now looking forward for your questions and the discussion on instruments and support schemes. Thank you very much.